Hi everyone and welcome back. After having learned all the different tools to deploy an application on Kubernetes, this entire section of the course will focus on automating all this as much as possible. We will start in this video by showing you the typical characteristics of a Kubernetes-based continuous integration and deployment pipeline. The problem is the following. Imagine that you have a Kubernetes cluster, and on that cluster you're going to run your application. That is not a problem yet in itself because you already know how to do that. But most likely you'll also somewhere have a repository that contains that application's source code. Often you're going to want your deployed application to update when the application's source code is modified, either for example on each change or when a new version like a new Git tag is released. And since you're probably going to get tired of rebuilding the same Docker image over and over again and then deploying it, you'll most likely want to automate this. And that's continuous delivery. A typical continuous delivery process consists of multiple steps that form kind of a pipeline. Usually a CD pipeline is triggered by an update to the source code repository. That might be a new Git commit or a new release in form of a Git tag. The first step you're going to do will then be building the application. How this is actually done is of course dependent on the technology that is used. However, since we're talking about deploying to Kubernetes, any kind of build job will most often produce a container image as build artifact. This image can then be used, for example, in a Kubernetes deployment object. Subsequent but optional steps of a deployment pipeline could consist of observing the application behavior after updating the deployment and triggering a rollback if the newly released version of your app does not behave as intended. Often, you want not just to release the latest version of your application, but rather a specific one. For example, if you have pushed a new Git tag, in this example version 1.5.2, you would expect your deployment pipeline to deploy that exact version to your Kubernetes cluster. Just as usual, you can build the application into a container image, and typically that image tag will match the just pushed Git tag. If you already have an existing Kubernetes deployment, your deployment pipeline can then use the kubectl setImage command to update a deployment specification to use that new image. Updating the image in the Kubernetes deployment object will then cause the deployment controller to start a rolling update to your new version, as you've already learned in the previous section. This works just fine. However, the kubectl setImage command requires that the deployment to be updated already exists in the first place. Also, this deployment pipeline will not apply any changes to the deployment specifications that are not related to the container image. Like for example, new environment variables, changes to config maps, new services, and things like that. As you may already have noticed, there are many different options and ways to configure a continuous deployment pipeline. Over the upcoming videos in this section, you're going to learn how to combine two powerful tools to fully automate your deployment and to solve all the issues that we've just been talking about. And these two tools are going to be GitLab and Helm.